Hello friends, in previous two videos we spoke about creating the PostgreSQL database that is fully encrypted using a data at rest encryption. In the coming videos we will create the SSL sockets and the key stores. Now, before the client can connect to the server and query the databases that within the server, we need to make sure that to create a connection between the client and the server and make sure that this connection is secure. Now, this process contains two sides, the client side and the server side. In the client side we will create the SSL socket and the key store, and on the server side we will create an SSL socket with multi-threaded and the key store. In the first two videos we will talk, in the next two videos we will talk actually about this part, and in the videos afterward we will talk about this part. Now, on the server side, I'll show you how you can create the SSL socket and the key stores using both ways, using the Java default provider way and also using a custom provider such as the Bouncy Castle provider. But on the server side, we will apply only the Bouncy Castle way in the real application. So we will not do it with the Java default provider. Now, on the application side, I will do the SSL socket and the key store using only the custom provider, which is in our case the Bouncy Castle provider, the PC JSSE. Though it's for some it's more complicated, but it's more secure and flexible. And I will focus on the Bouncy Castle JSSE to create the key store and the SSL socket, and we will use also the FIPS mode with the Bouncy Castle JSSE. And the FIPS mode is just a standard used for the US government employees, and we will see how we can implement it in our application and in our SSL socket creation and in our key store also creation. This use of the Bouncy Castle JSSE with the FIPS will elevate our connection socket security standards. This is the whole point. Okay, so let's dive in, and as usual, as I usually do, I create these steps. I will go through them one by one just to tell you simply what items or what steps that we will use to create the SSL socket and the key store, and then we will implement all these steps. After I finish talking about them, we will implement them in a real world. And the objective of these steps is that we need to create this socket which will enable the client to connect securely to the server and query the databases. This is the whole objective of our work. The steps consist of 11 steps, and I will go through them one by one, and as I said, once we finish talking about them, then we will implement them practically on an application. The first step is that we need to do two things with the first step. The first step contains two parts. First, we need to change the policy to unlimited. The Java security policy, we need to change it to make it unlimited. Now, since by default Java security used only 128-bit for security, and since we are going to use the Bouncy Castle, and then which we will use 256-bit of encryption, then we need to change the policy of the Java security tool and make it unlimited. And we will see how we can change the policy in two ways, either using the Java security file or another dynamic way to change the policy. Now, the second part is that we need to create a binary file on our application class path. This binary file will act as a seed for the key store that we will create later on. Now, step number two is that we need to implement our custom Bouncy Castle provider by setting up the priorities to 1 and 2. Now, by default, Java security uses its own providers. It has a list of its own providers, the default providers for the Java security, starting with Sun provider, which have priority number 1. Now, since we need to use a custom provider, then we have to set our own provider and we give it a priority 1 and 2. And this will make the implementation of our custom provider implemented on our application rather than the Java security provider, default provider. And the other thing is that we need to add the jar files of our custom provider into our application so that the implementation can happen on our application. Otherwise, if we don't add the jars of our custom provider, then it will default to use our application will default to use the Java security default providers. So make sure that you add the jar files of the custom provider to your application library. And the last thing is that we will learn how we can set this provider to work as a globally or locally, and we will learn what the meaning of the globally or locally and how we can implement them, how we can set a global provider or a local provider implementations. Now, steps number 3, 4, and 5, all of them related to step number 6, which is creating and initializing the SSL context. SSL context requires 3 things: key managers, trust managers, secure random. Step number 3, create the key managers. Step number 4, create the trust managers. Step number 5, create the secure random. And it is all seen in here, as you can see. So when you need an SSL context, you need the key managers, you need the trust managers, you need the secure random. This step number 3, this step number 4, this step number 5, and all together combined will give me and initialize the SSL context. Now, step number 7 is that we need to create an SSL socket factory for this client side, for this application side. Step number 8, we use, of course, step number 7, we use the SSL context that we have created in step number 6. Step number 8, we will create a client socket using the SSL socket factory we have created in step number 7. Step number 9, we do some properties. We give some properties to this socket, this client socket, this application socket. Step number 10, we will start connecting and handshaking between the client and the server. We will do the connection and the handshaking. Step number 11, which is the finale of our work for the client side to create the SSL socket, is that we will get the session. And this is the objective of all our work. As you can see here, the objective is that we get a session between the client and the server. This session will give me all properties, all attributes of the characteristics of this connection. So this session will happen only after a connection and a handshake has happened between the client and the server. And this session has some attributes which I can find them, all about them, using this SSL session object, and we will see which are the attributes that we can know about the session, all the details from it. One more thing to mention, that in this video I will talk about this part of the SSL socket part. As I told you in here, this side, the client side, has 2 parts. First we create the SSL socket, and then we create the key store. So in this video I will talk about creating the SSL socket, this part for the client side. In the next video I will create the key store for the client side. So 2 videos. This video I will focus on this side, create the SSL socket. Next video I will create the key store for the client side. And you can see it in here. So these steps, all these steps about creating the SSL socket, except for the client side, of course, except these steps concern the creation of the key store for the client side, and this two-step as well we'll discuss on the next video, which also concern the creation of the key store. So these steps and these we will talk about on the next video. Okay, now having said that, let's dive in with the real implementation, the practical implementation. And we will start with the first part of step number 1, is that we need to change the policy of the Java security from limited to unlimited. Now, first thing you need to find out, where is your JDK saved on your system, Now, in my case, I will find it out in here. I have saved my JDK on user local JVM, then the JDK, and this part I need to focus on. Now remember, the JDK in my case in this directory, but in your case could be anywhere else, so you need to find out where is your JDK in your system. Now, two things you need to notice about this JRE folder. First of all is that all the work that we will make about the security, about unlimited security, about any changes about the security, we will make on this JRE. That's number one. And number two, you need to package this JRE with your application final version, with your production version that you will export to your customers. So your production version, your final version should contain this JRE that contains the all the adjusted security policies of your application. Now, if you don't package this adjusted JRE with adjusted policies, with the unlimited policies, in your application, in your production version, your application will not use unlimited policies, will not use the Bouncy Castle implementation. It will default to use the Ssl provider or the Java security default providers, which uses only 128-bit of encryption. So you need to make sure that you include this JRE, which you have changed the policies in it. You have it included in your application, in your production version. Other thing to notice is that this JRE should be maximum of JRE 8. JRE 8, it should not be of JDK 9, 10 or 11 or 12 even. So it should be of JRE 8, version 8. And the reason for that is that you see, we said here that we will use the Bouncy Castle provider. Now, until today, now we are in March 2019, the Bouncy Castle guys have tested their package of the Bouncy Castle only up till JDK 8. So the Bouncy Castle provider package, all jar files, they are tested only up to with JDK 8. It's not tested to work with JDK 9, 10 or 11 or even 12. So you have to have in your application the JDK or the JRE 8. Should not package the JRE 9 or 10 or, because it will not work. The Bouncy Castle is not tested to work with higher than JDK or the JRE 8. This is the reason that you need to make sure in your application should have JRE 8. So this JRE should be JRE maximum 8. Probably in the future the Bouncy Castle guys will create a new version of the Bouncy Castle JSCC with the FIPS mode that is compatible, that is tested with the JDK 9, 10 or even 11. But so far, it is March 2019, it is tested only with JRE 8. Okay, having said that, let's start changing the policy, the library. and then the security, we will open this folder with a terminal, and then we will open the folder itself. Now notice here we have one file by the name of Java Security, which contains all the configuration of the Java Security, and we will open this file. So the first step is that we need to change the policies in here, and the other step is that we need to add the jar files of the unlimited Java Security, which is in here. So the first thing is that the section that we are interested with is almost at the bottom. It is, so we need to go all the way to the bottom. This file, as I said, contains all the configuration of the Java Security. I think we skipped it. Let's go back. Here, this is the section of the limited or unlimited policies. From this section you can learn it, this limited or unlimited. If you go down here to this line exactly, you see this line, crypto.policy equal unlimited. By default it is commented, which means that your Java policy is limited. So what you need to do is that you uncomment this line of code. So you will have crypto.policy equal unlimited. Now your policy will be unlimited, and you can use an encryption which is higher than 128, 256, possibly 512. Now you need to save the file. This is the first step. Now the second step is that you need to add the jar files of unlimited policies. Now in some systems, for instance my case, I'm using the Ubuntu, already there is these jar files saved in the system by the name of policy. So if you see here, this is the limited and this is the unlimited. These are the two jar files that you need to download. If they are not in your system, you can just Google them, you can download them, and then you need to package them with your jar file, that with your JRE folder that you will add to your production version of your application. You have to do that. As I said, if you don't do this, your unlimited policy will not work on your application, on your production version of your application, and therefore Bouncy Castle will not be implemented, and it will default to use the Java Security default provider, which uses only 128-bit of encryption. Okay, so these two steps, these two jar files of the unlimited policy, alongside with changing this file, make it unlimited. This way is the way to change the policy of your application to use unlimited security, unlimited encryption. Now this is the regular way using the Java file, the Java security file. There is another way, should I call it as a dynamic way, which is this way, but this way implemented only on Java 9 and higher. Java 9 and higher, it can be implemented to change the security policy of your application. I'm not sure, you can try it on your, since you will use Java 8, so you can try it, probably it will work, probably not. If it doesn't work, then you can go with what we have just said now about changing the policy and do it. But you can try it. This will change your security policy dynamically, which is obviously is a more easy way. You can try it if it works or not. Okay, now this way we have finished changing the policy of our application. We have changed the policy in the JRE. The JRE should be JRE 8. Once we have changed the policies, we should package this JRE into our application, into the production version of our application, so that the Bouncy Castle implementation use unlimited security for our application. Now the second step is that we need, as I said, we create a binary file to work as a seed for the key store, and the way it is very straightforward. You just create a file and whatever name of your file, and you can set it with some input upstream, and so you can make it as a binary file, and it's just a normal way to create a binary file. That's it. Now step number 2 is about the provider, the custom provider. We said that we have 3 things. First, we add the provider and we give it a priority. The next step is that we add the jar files to our application, and the third thing is that we make it globally or locally. So let's start one by one. First thing, you need to add the provider and set its priorities to 1 and 2. And the way to do that is pretty easy. If you want it globally, you can do it globally. It will affect the entire system of yours. All the system of yours will be affected. So the Bouncy Castle implementation will cover all your system, whatever system, not just your application. This is globally if you implement your Bouncy Castle. Now there is another way, which is locally. If you go like here, this implementation will make it locally. It will give you a priority 1 and 2 for your Bouncy Castle, but this is locally, will affect only your application. It will not affect your entire system, your entire whichever system of your application. So this is the 2 things. First, we made the priority of our Bouncy Castle, and second, we made it locally or globally, and we know what is the differences. The third thing is that we need to add the jar files to our project structure, which is pretty straightforward. These are the jar files. You just add them and make sure that you are using the FIPS mode, because there are normal ones and there is ones with the FIPS mode. So make sure that you will use with the FIPS mode, the jar file that contains with the FIPS mode. This is all about the setting the Bouncy Castle provider as your number 1 and number 2 providers. And by the way, you can see those providers again. If you look at this file again, you could see these providers here. Now by default, this is the Java security providers. Started with priority number 1 for the Sun up till 9 for different providers. Now if you make this dynamically, if you add these providers dynamically here, these providers, the Bouncy Castle will take number 1 and 2, and Sun will be number 3. So this is the benefit of using dynamic insertion of the custom Bouncy Castle priorities. Okay, and this is all about the custom provider insertion. The next step, the step and 4th and 5th related to the step number 6, as I have mentioned. Okay, so as I have showed you before, the process is backward. The objective is to create this session. We need socket for the client. We need factory. We need context. We need these. three things to initialize the SSL context. And we can see these steps arranged in the application like this. So this is the goal, this is the session. In here we will do the exchange of data. So whatever happens in here, this will be the exchange of data between the client and the server. The client connects to the server and querying the databases. This will happen here. But before that, we need the SSL session. This will take an SSL socket. This will take a factory. This will take a context, trust manager, and key manager. This is the steps backward. So, and I have created them as methods, one after the other. Whenever one succeed, then we can get the next step and next step until we reach to the session, which is the goal of our work. So we will go with these methods one by one after the other. The first one is to create the key managers. Now, if we see here, the key managers is simply, as I have said probably before, it's a vault. It's a vault to save the key materials. The key materials are the encryption keys. The encryption keys that we will use later on when we make the SSL socket and we will make the authentication of the connection between the server and the client. So this is the key manager. It's just a vault to save the key material, that is the encryption keys. So we need to create the key manager factory and initialize it, and first of all we need to create the key managers from this. So this we will do in the first method, which is this method, create client key manager, and the steps are in here. So the first step is that we need to create the key managers. So to get the key manager factory, we will use the key manager factory class, and we call this method get instance, which take two arguments, the algorithm and the provider. And provider in our case is the Bouncy Castle JSC, and the algorithm is PKIX. And you can find about this class in here. Now the algorithm, you can find the details about it in here. The key manager factory algorithm, the PKIX, which takes a factory, which is a factory for the key managers of type X509. Remember, when we create certificates and keys, we use the type of X509. That's why we will get this PKIX algorithm type. And the key managers, which is class, this class, the key managers class, is just a class to create the key managers. So it's just a class to create the key managers. Remember, we said the key managers is just like a vault to save the key material. The key material in this case is the encryption keys. So each key manager will hold and save one type of key material, one type of encryption keys. And the key managers class, the key manager class, as definition says here, the interface of key managers is, as the definition said, it's a key manage the key material which is used to authenticate later on the local SSL sockets to its peer. So whatever we will get here is we will get a key manager that will hold and save the key material, that is the encryption keys. Each key manager holds one type of encryption keys, which we will use later on to authenticate when we use the SSL socket. So back to here, once we use this class, the key manager factory, we will get a key manager factory instance object, and then we initialize it. We initialize the factory using this method, and we call this argument. Now these steps, as I told you before, we will discuss in the next video because it's related to creating the key store, so I will not go through them now. But the point is that we need to initialize the key manager factory with this argument, and finally we use this initialized key manager factory object to call this get key managers, which will give us the key managers. This will be the first argument. The first argument when we initialize the SSL context. The SSL context requires 3 arguments: key managers, trust managers, secure random. Key managers from step number 3, which we have just discussed right now. Now the next method, once we have got our client manager, the next method is the trust managers. In the same fashion, we create a trust manager factory, calling the trust manager factory class. Call this class the get instance, and again the trust manager use only one algorithm type PKIX, because the certificate uses the type of X509 again, and the provider, our provider, the Bouncy Castle provider. So once we got the trust manager factory instance, we need to initialize it, and then we need to create the trust managers. 3 steps: create, initialize, get the trust managers. Now the trust managers, on the other hand, is a vault to save the certificate material, that is the certificates, and each trust manager will hold and save one type of certificate. So the trust managers hold the certificates, the key managers hold the encryption keys. Now to initialize the instance of the trust manager factory, we call this method, and we use this argument. Now there are 2 ways to initialize the trust manager factory. If you have only one certificate or one CA, certificate authority, that is saved in the key store, then you can go for this method, for this argument. You use the key store directly. Now if you have multiple CA stored in the certificate, then you need to find out which CA you need to use with this server so it can authenticate the client. So you need to use this argument, the trust store managing factory parameters. I will go through it shortly, and then you can get trust managers, which is the second argument in initializing the SSL context. Now these 2 things, I will talk about them in the next video. So I will talk about them because they are related to creating the key store. So I will talk about them in the next video. But the point is that if you have one CA stored in the key store, you go with this argument. If you have multiple CA, then you need to figure out which CA this server needs to use to authenticate the client. So you go with this method. Once you have initialized the factory, the trust manager factory, then you use the object to call this get trust managers, and you will get the trust managers to hold and save the certificate material, that is the certificates. Now this is the second argument, as I have said, in initializing the SSL context. Now the third method is that we need to initialize the SSL context using these 3 arguments. The third argument we haven't created yet, which is the secure random. Now when we use Bouncy Castle, we will not use the default secure random class of the Java. Now we will use another customized class that is created specifically for the Bouncy Castle. The class name is DRBG. Now what is this class, the DRBG? The DRBG class, you can find all the details about it in the GitHub, and this is the link where you can find all the details about. The DRBG will give you use 3 methods. Actually it gives you 3 methods: set default DRBG, build DRBG, build the RBG for keys. Each method will give you, each static method actually will give you a secure random that is specifically designed to use with the Bouncy Castle, and each one will have a specific use with some application. So you need to find out which one of these three types of secure random you need to use that is suitable for your application. In my case, I'm going for the build the RBG for keys, which is the third one. So you need to find out which one of these three methods is suitable for your case to give you a secure random. So when you use the Bouncy Castle, we will not use the secure random class of the Java. We will use this customized class to get our secure random. Once we have the get secure random, then it is the third argument to initialize the SSL context. Now once we have initialized the SSL context, that means this part have been completed. Actually, initializing, creating the SSL context and initializing the SSL context, this part have been completed, only this part. Now, the next method is that we will create the SSL client SSL factory. And the way to do that is that we use the SSL context that we have just created it, which is this one, this instance of the SSL context, and call the get socket factory. Get socket factory. And this will give us an SSL socket factory object. So the client SSL socket factory, because we are working now on creating on the side of the client, on the side of the application, to create the SSL socket. So we call this method using the SSL context. We will get an SSL socket factory. Once we have got, but first of all, let's understand, sometimes we use some names that we don't understand what are the meaning of these names. So what is the name of, what is the meaning of the factory? Now, the factories actually encapsulate the details of creating and initially configuring secure socket. So the factory is merely encapsulate the details when we create a secure socket. Details such as the authentication keys, the peer certificate validation, the enable cipher suits, all these details about the secure socket, the factory will encapsulate in one object. This is the meaning of the factory. Now, once we have got the SSL socket factory object, the next step is that we need to get the SSL socket for the client with this method. And the way to do that is very simple. The same factory which we have just got it, we call this create socket. Now, notice that this socket will only create the socket. It will not connect to the server. If you use this method, it just create a socket. It will not connect it to the server. Now you need to cast this to an SSL socket to get a client SSL socket. I have seen some fellows falling into one mistake. Now when they use this object of the factory and call this method, they leave it to the default result. The default result will give you a socket, an ordinary socket. Now this socket is not a secure socket. The SSL socket class extend the socket class, but the SSL socket adds extra features for security, such as the SSL, such as the TLS, DTLS. So you need to, when you create the socket, you need to cast it to get an SSL socket, not just a socket. So be careful when you do this step. So once you have cast it, you have now a client SSL socket, a secure client socket. Now once you have got the socket, you need to add some parameters to this socket. But before that, you need to know which cipher suite is available in your system. Now, what is the cipher suite? The cipher suite is just a combination of algorithms. That's it. The cipher suite is a combination of algorithms that is available in your system. So you need to know which cipher suite is available in your system and the way to do that, and then you assign this cipher suite to your socket. The way to do that is that you call this method. So use this socket dot get enable cipher suite, which will give you a string array, names, all the names of the cipher suites, all the names of the algorithms that are available in your system, and then you use this list, add this list to your socket using set enable cipher suite. We will see later why we need to do this step. Now, once we have done this step, now we need to start adding some parameters, some features of our socket. What are the features? What are the parameters of our socket? And the way to add the parameters, which is, as we see here, is step number 9. And the way to add the parameters is that you create, use this class, the SSL Parameters. So from this class you will get an object of this class, and then you use it to add the parameters that you wish to add to your socket. And you can find the details about this class in here with the SSL parameters. You can read about, and there are a lot of parameters that you can add. You see here, set cipher suite, set application protocols, a lot of set endpoint authentication. I have chosen a few of them and I will talk about them. So the first one is the set cipher suites. Now, cipher suite, as we said, they are the combination of algorithms that could be used with your SSL socket of your client socket. For the Bouncy Castle, now you need to know from where you can get these cipher suite. If you go to this article, the name of it is this one, Legion of Bouncy Castle Incorporation. This is the name, and if you go to this side, this page, these 2 pages, it will mention to you all the cipher suites and which one is enabled for the FIPS mode. So these 2 pages you can select. You need to know which one is suitable for your case, so you can use the cipher suite in here. Obviously you have to check which one is suitable for your case. Now the second parameter is send endpoint identification algorithm. Now this one is a little bit important. Why? Because we need to know which algorithm we will use to make the handshake. The handshake usually is when the client connect to the server and tell the server, hey server, can I connect to you? Now this process of handshake requires that both the client and the server should use the same algorithm. They must use the same algorithm so that the handshake process can succeed. If the handshake fails, the connection will fail, and there will be no socket, and there will be no connection at all. So you have to make sure that both the client and the server use the same algorithm so that the handshake can succeed. Now the set protocols of the encryption, protocols. Now the normal one we used TLS v1.2. Now there is another newer one, the TLS v3. Also it's available now. You can use it if you wish. I'm just using the v1.2, and then you can add other parameters if you wish. As I showed you, there are multiple parameters you can choose if you wish. So I just choose the basic ones. Now once you have done, then you have to set these parameters. All these parameters you have to set them to this socket using the set SSL parameters. Now about this one, set TCP no delay equal to true. Usually when the data goes from the client to the server, it goes as, it's buffered and then goes as packets. So the system will buffer these data and send them as packet. If you set this socket, set TCP no delay to true, if you set it as true, then there will be no buffering. Whatever data comes from the client, immediately it will be sent without any buffering, without any delaying. So supposedly this will enhance the performance of the connection. It totally depends on you if you wish to use it or not. Now here, step number 9 have been finished. Now we come to the step where we do the handshake and the connection with the server. Now the connection process and the handshake process consists of few steps. One of the steps is that you call the socket, the client SSL socket, and explicitly call this method, the connect method. This method will explicitly connect your client to your server. You remember here when we said that create socket is just creating the socket, it will not connect to the server. Here we are using this method to explicitly tell the socket to connect to the server. Now here we need to know where is the server, what is the details of the server, which is the port, what is the IP address of that server. So we need to get a socket address class which will take an interface which will take the inet socket address, and this one we use the inet address.get by name. Here we add the IP address of our server, whichever server you are using, and the port of that server. Now in my case I'm using a PostgreSQL server, so the port has one port, is 5432. In your case you need to see which port you are using and you have to add it in here. So the IP address of your server and the port of your server, so you can get the socket address, so you can tell your socket, your client socket, explicitly to connect to that address of the server. Now once the connection is made, now we need to go with the handshake. Now for the handshake we will use an interface that belongs to the Bouncy Castle. This is the interface, the BC SSL socket. So let's see what is this interface. The BC SSL socket is merely extending the SSL socket, the regular SSL socket, but it adds more functionality, some other functionalities. One of the functionalities is this method, the get connections. And this method, if we use it, will return to us a BC Bouncy Castle SSL connection. So this method will give us this connection. What it do? Here, this is the definition, if you can read it in here, which is mentioned in here. This method, the get connection, will initiate the initial handshake if necessary and then block until the handshake has been established. If an error occurs during the initial handshake, this method returns null. So this method will ensure to us, will make sure that we have a successful handshake between the client and the server. If the handshake fails, we will get a null and there will be no socket and there will be no connection. So by using this interface, we are having a good reliability that we will get the handshake or we are not. And this method will make sure that this will happen. And we will get a Bouncy Castle SSL connection after the handshake has been completed. Once the handshake completed, that means our connection has been set totally, and the objective of our creating the SSL socket has been made. We have now an SSL socket and we have a connection between the client and the server. Now to make sure that the session has been established, we need to go for the last method, the create SSL session. Now what this will do, the SSL session have some attributes, a lot of attributes that tells you the characteristics of this connection, of the current connection, of the current SSL connection, after the connection has been made. After the connection has been made, the SSL connection, then we can use this SSL session object to see what are the attributes of this connection, such as attributes such as get cipher suits, get peer. Let's see if client SSL session dot. You see there are a lot of attributes that we can tell us a lot about this connection after the connection has been made, such as the ID, the last access time, and a lot of local certificates. So many attributes which can tell us a lot of data, a lot of information about this SSL current connection. Once we have reached to this point, that means the objective is totally performed, and here we can start connecting to the server and doing some code. That depends on you, of course, how you do the code to connect to the server and query the databases. This is all will be done in here by you, depending on your case. But the point is that now you have a secure connection. You have now, once you have reached to this point, you have now a secure connection, an SSL secure connection between the client and the server, and then you can start connecting to the server and querying the databases by adding your code in here to get the data back and forth between the client and the server. Now this is the video number 1 to create as I said, this is the video number 1 to create the socket for the client side. In the next video we'll talk about creating the key store for the client side, and the next video will focus on these steps for the key managers and on these 2 steps for the store manager, for the trust manager, sorry. Okay, thank you very much for watching.